Hi, welcome everybody to the Energy and Sustainability Community of Interest webinar. Thanks for joining us again for another informative and interesting webinar. We're going to talk today about the importance of building decarbonization and how ASHRAE can help. We've had great turnout for the first two webinars of the year, and I'm looking forward to seeing how many we ultimately have calling in today as well. My short bio, if you're familiar with the webinars, you should be a familiar face to you now, Matt McCann. I am a retired Navy Civil Engineer Corps officer who had a heavy focus on facilities management and energy efficiency during my career. And I've been with AECOM for about 6 years now since I retired from the Navy, working as a federal energy market sector lead. Let's get a couple of administrative things out of the way. You may have challenges if you're trying to connect through a VPN, so our recommendation is don't do that. If you're having trouble connecting audio, you may not be able to hear me right now, but hopefully you can see the kind of instructions for troubleshooting that there. There's a couple tabs off to the right you should see. Please, if you have questions, and I do encourage everybody to post questions here for our speaker, please put it in the Q&A tab. There's also a chat tab you can see up there for if you have technical issues or if you want to share anything else. I'd love to see people posting, who they are and where they're from in the chat tab. So if you're interested in doing that, please go ahead. And then you can download the slides from the handouts tab. As always, and as usual, we started the recording right at the top of the hour, and those recordings should be available in about 10 days or so. Short update on the COI or things to know. As always, if you're interested in serving on the steering committee, please contact Michelle. She's always looking for folks to help out. If you don't know specifically what you want to do, just reach out and we'll find something for you to help out with. A few upcoming events. Tomorrow is an environmental COI, intergovernmental engagement webinar on PFAS. That should be really fascinating. JETC, of course, is coming up in a couple weeks. Hopefully you're all registered for that. JETC will, of course, have a COI, an in-person COI meeting, which should be exciting. Please come out if you're going to be at JETC. Bring a friend, even introduce them to the COI. We'd love to get as many people in the room as we can to talk about what's going on. And our next webinar will be in June. We typically don't do a webinar in the month where there's a big SAME event. So no webinar next month. We'll do one in June on EV charging infrastructure, kind of continuing this year's webinar series on topics that align well with the administration's priorities and Executive Order 14057. Infrastructure bill funding impacts, advanced water conservation, carbon capture technologies, and a bunch of other stuff will be coming up for the rest of the year. And then one last administrative item, we like to do a poll to kind of see who's on and get an idea of who's joining the webinar. So if you could answer the poll question, which should be popping up right about now, I think. Hopefully that works. There we go. And then while that is up, I will do a short intro on our panelists today. I feel really lucky to have landed really a legendary panelist today. So Don Brandt has been involved in the HVAC industry for 47 years. He's an ASHRAE and IEEE life member. He teaches a bunch of classes, including CEM prep course, HVAC design essentials. He's an author. He wrote Fundamentals of Psychometrics, 2nd edition. He's got plenty of energy-related certifications. He's received many awards, including ASHRAE's Distinguished Service Award, Exceptional Service Award, and the Fellow Grade Award in 2020. And he's going to talk today about his current membership and the task force on building carbonization and what ASHRAE is doing there. So Don, please take it away.
Matt, thank you. I look forward to our presentation here. And enjoy the opportunity to speak to you folks. So this is our learning objectives, which basically is our agenda. We'll talk about some fundamentals of building decarbonization. We'll talk about some common building decarbonization terms or definitions, if you will, as such. We'll review the ASHRAE Building Decarbonization Position Document. And the issue that I'd like to bring forward is we actually approved it. Our task force actually approved the document yesterday morning. And then we'll talk about things moving forward, like ASHRAE will have a standard related to building decarbonization. We've already approved the standards formation. Now we're populating it, and we will have an announcement on that. The goal will be to get a standard by early sometime in 2023. So now, why do we decarbonize buildings? And there's many sectors of the world that can be decarbonized. Since ASHRAE is, we consider ourselves building experts, we're going to focus on, buildings themselves. People that are in the utility business, they're going to go ahead and do, their things related to utilities. People in transportation, they're going to do their things. We've decided we're going to stay out of that mess. We're going to simply focus on decarbonization of buildings. Now, a couple of items. So climate change is the most formidable environmental challenge, ever faced by society. Aggressive and sustained reduction in carbon emissions are required to limit climate change. Here's a big one. Buildings represent 39% of the global carbon emissions, and the global building stock is expected to double by 2060. So a short 38 years away. New buildings have a 40-plus year lifetime, locking in emissions for decades, and urgent action is needed to minimize the carbon emissions in the building sector. So these are the common greenhouse gases that we see. These are the 6 top ones. So these are the 6 ones that we're chasing. Obviously, carbon dioxide is, the top one. So again, the combustion of fossil fuels relates in, carbon dioxide emissions. Methane is kind of the second one, and methane is the primary component of natural gas. So the natural gas industry isn't exceptionally good about fixing leaks, especially from well to the processing station. But then also landfills as garbage decomposes, and then also the sewage treatment process. If you're familiar with that, the digesters, they give off methane. Now, in a lot of cases, I'll be happy to say that most of the boilers that heat the digester to, aid the process, they burn the methane in those boilers, and that certainly reduces the amount of direct emissions to the atmosphere. Nitrous oxide, obviously a product of the combustion process. So we see the need to reduce that. HFCs, hydrofluorocarbons. So they're used in the semiconductor manufacturing business, but also some of the major refrigerants that we use this day and age. R134A, a medium pressure refrigerant, and then also it is a blended in with R410 are HCFCs, and that's our high pressure refrigerant this day and age. We have PFCs, so we have the parafluorocarbons, so they're used in aluminum production, but also in medical imagery. And then last but not least, sulfur hexafluorane, used in electrical transmission, and the part of the F6 that's used is actually the high voltage circuit breakers. So when you talk about utility grade circuit breakers, 345,000 volts, 500,000 volts, 750,000 volts, this gas is used to suppress the arc that obviously is generated when you open up a feeder that's got, maybe 1,000 amps flowing through it at 500,000 volts. So certainly very important, and also in magnesium production. So building decarbonization. So the definition of it is the process of removing and reducing man-made carbon emissions related to the building with the goal of eliminating them altogether. So this includes carbon reduction in the carbon reduction in the manufacturing of many materials, and also includes a reduction of carbon emissions in the operation of the building. So one of these we're going to call embodied carbon, the other one we're going to be called operational carbon. So our task force at ASHRAE was formed in February of 2021. We have 15 members. I'm one of the members. We have 10 working groups, which we focus on different phases of the building decarbonization process. We have global representation from all over the world. And with the 15 members here and then the additional members of the 10 working group, we actually have about 120 total volunteers working on this particular issue. This is our website, and we encourage you to visit it, when we're complete here. As we get additional information, we are continually updating this, and there's lots of information available to help you with your understanding. And then eventually, as we develop a standard, ASHRAE has a standard on building decarbonization, then information related to that will be available on that. Refrigerants. So as we see, refrigerants certainly are one of the emissions that leads to global warming. And what I've done is I've picked here a couple of our current refrigerants that have relatively high global warming values. Low pressure refrigerant R123 used in centrifugal chillers only has a global warming potential of 77, which is a relatively low number compared to the other two here. And it has a ASHRAE safety group classification of a B1 refrigerant. R134A is a medium pressure refrigerant. It has a global warming potential of 1,430, and it has a safety group classification of A1. And then last but not least, R410, which is a high pressure refrigerant used in residential and unitary type equipment, has a global warming potential of 1,920 and is also a safety classification of A1 refrigerant. Now, refrigerants that are currently available that are low GWP and will become available in the relatively near future. Low pressure refrigerant, which would be a replacement for 123, would be R514A, has a global warming potential of 2 and is a B1 refrigerant. CO2 is actually a refrigerant. It's used relatively sparsely, especially in the United States. One of the issues is because of our ambient temperatures, you get really, really high condensing pressures. So it tends to be used in Northern Europe a lot, or areas of the world that are relatively cold. It has a global warming potential of 1, and it has the value of 1 simply because that's the metric that we're comparing everything to. It is an A1 refrigerant. R1233ZD is also a low pressure refrigerant, has a global warming potential of 1. Has an A1 safety classification. One of the replacements for R134A in automotive is R1234YF. It has a global warming potential of 1, and it is an A2L refrigerant. Now, these refrigerants are all high pressure refrigerants. They are replacements for 410A. None of these are currently available in the United States because they haven't been adopted into the code. The next code revision that we will see is the 2024 series of the International Code Council code. So the International Mechanical Code doesn't have all the items in it related to safety for these refrigerants. But we've got R452B, R454B, and R32B all have global warming potentials in the 400 to 600 range. They're all A2L refrigerants. And A2L refrigerants, just as a refresher, are basically what we call mildly flammable refrigerants, and they have a relatively slow burn velocity. That's why they're separated from the rest of the A2 refrigerants. What I would like to point out is one of these low GWP refrigerants is R466A. Has a global warming potential of 733 and has an A1 safety classification, which will then separate it from the A2Ls in the places that it can be used and the charge limits that you will see from that. Okay, so part of the decarbonization process is we can't forget about energy efficiency. We still really have to build a good building. So we want to optimize our envelope. Our envelope is our walls, our windows, our roof. We want to be careful what our wall to window ratio is by exposure. We want to maximize daylighting. And when we say maximize daylighting, we want to make sure that it's properly shaded. The last thing we want to do is get daylighting in, reduce our lighting load, but then add solar heat gain, which then obviously would cost more to cool the building. We want to focus ourselves on high performance air conditioning systems. And I would bring two of those to your attention: radiant heating and cooling panels at the ceiling, and also chilled beam systems. They both have the ability to have zero terminal airside horsepower at the zone level. So they're different than any other systems that we've had available in the past. Hopefully you've had experience with both of those. Dedicated outside air systems have come to the forefront probably in the past 12 years. One of the advantages of dedicated outside air systems is we get to pre-filter all the outside air that's required for proper ventilation of the building, but we also get to preheat it, pre-cool it, and dehumidify it before we actually send it into the zone. LED lighting. With LED lighting, we're able to get lighting levels down to somewhere around 0.2 to 0.3, maybe as high as 0.4 watts per square foot, which is way better. When I started in this industry way back in 1974, it wasn't uncommon that we would see lighting levels in commercial office space at 2 to 3 watts a square foot. So we're 1/10 of that number with LED. Site orientation. So how we site a building if we're going into new construction, is it possible to minimize the east and the west exposure and maximize the south exposure? Simply for the fact that, in the summertime, we minimize the amount of direct sunlight on the east and the west exposure, and with a certain amount of shading at the latitudes that we have in North America, we're able to shade the windows in the summertime, but pick up the benefit that the sun would provide in the wintertime to, provide quote unquote free heat into the building in the winter months. On-site renewable electric generation, so whether you're doing wind turbines or whether you're doing PV, those are all good things. And then certainly adding EV charging stations to our buildings of the future is an absolute necessity. Okay, this is the carbon life cycle in a building. Let me just kind of explain this. First of all, this comes from Europe. It's a document that's called EN 15978, which if you just Google that, it will come up. These are the various, there's actually a learning module for each one of these. So you have the A's, the B's, and the C's. So this is the time as we start talking about the various products and the various items that we go through to build a building. And the embodied carbon is the carbon that's in the materials. And when we talk about the products, the embodied carbon is the carbon that we spend to extract the raw materials. So whether it's lumber, whether it's mining of ore, mining of copper, the things that we see in buildings, we then have the carbon expanded by either diesel fuel or gasoline for transportation to the factories. And then the manufacturing process, generates some amount of carbon. Some of these are very intense. Take a look at the effort to make, cement. Take a look at the effort to make steel and how much carbon is involved there. So now what we do is we're now in the construction process and we have embodied carbon. Now it ends up being associated with the building simply because it costs carbon to transport all these materials to the site. And then all the construction activities associated with constructing the building itself is also embodied carbon. So obviously we're expending carbon to move materials around the site. And also all the workers, the workers, drive to the site every day, drive home every day. So there's carbon used there. So then that embodied carbon stays in the building, but then once we start using the building, then we end up with all operational carbon. So the use of electricity, the use of natural gas, the use of a number 2 fuel oil for boilers, just as an example of all the operational carbon that goes into the building, plus the fact that the, people that work in the building, they are using some form of transportation to get to the building itself. If they're using personal cars, this day and age they're using internal combustion engines, but the hope is in the future that they will then have electric vehicles and that they'll be able to use some form of mass transit which then could be electric powered. And then, of course, the total hope is that the electric grid at some point in the future is a combination of renewables and nuclear power so that we have the ability to support the existing grid with basically electric generated with non-carbon sources. Last but not least, when we're ready to get out of the building itself, the embodied carbon that is, we count in our end of life of the building sector is the demolition of the building, the hauling the waste materials away, and then landfilling or recycling. And as time goes on, we're hopefully that we're going to see the recycling dramatically increase. Okay, so decarbonization standards and codes. So many parts of the world are engaged in building decarbonization movement with hoping for net zero carbon by 2050. I'm going to be perfectly honest with you. I think that's a very, very, very ambitious goal. I'm not sure that, the world is ready to get there and make the commitments that are necessary. One goal for the task force is to set the stage for integrating building decarbonization into ASHRAE standards. One of the things that we did when we first started this effort is we put together a complete list of existing codes and standards as related to building decarbonization. And again, you're certainly welcome to visit the website that ASHRAE has set up. And we've got a PDF document, I think that is about 8 pages long, from all types of decarbonization codes and standards that are available from many different organizations and from many different parts around the world. So building performance standards. So BPS, they are part of an increasingly important policy tool for cities and states and governmental entities. Certainly the federal government at some point will have BPSs for decarbonization, looking to reduce the carbon impact for the built environment to meet our climate commitments. And also this gives us the ability to improve existing building performance. So basically renovating an existing facility, use for measured data and to establishment of increasingly stringent, performance requirements over time. Okay, this is kind of a boring section of the presentation, I'll be honest with you. I've got 6 slides here where I talk about definitions and terms, but I think it's important that you understand what each one of these is. And one of the disadvantages is if I try to ad-lib these, I may misspeak. So forgive me for just going ahead and reading these, but I think that's the best way to convey the message accurately. So carbon metric is a standard measure of carbon dioxide equivalent emissions, abbreviated CO2 small e for greenhouse gases. So then carbon dioxide equivalent, CO2e, is a measure used to compare the impact of various global greenhouse gases based on their 100-year time horizontal global warming potential, GWP. CO2e approximates the time-integrated warming effect of a unit mass of a given greenhouse gas relative to that of carbon dioxide. And in GWP, we've seen the GWP values that I showed you for various refrigerants. An index for estimating the relative global warming contribution of atmospheric emissions to a particular greenhouse gas compared to the emissions of an equal mass of carbon dioxide. So operational carbon is the CO2e emissions during the normal use of the building during the life of it. And then the embodied carbon, so all the CO2e emitted in the producing of materials, it is estimated from the energy used to extract and transport raw materials, as well as emissions from the manufacturing process. Embodied carbon of the building includes all the emissions from the construction of materials, the building process, and all the fixtures and fittings, as well as deconstructing and decomposing it at the end of its life. Now, I do want to point something out here. There are groups that basically have 3 of these: operational carbon, embodied carbon, and then down here, a third one would be end-of-life carbon. So what we would do is we would take these items out here, the destructing and disposing of the building at the end of life, and we would put them into a separate bin called end-of-life carbon. So if you see that, you know what it's for. Okay, so emissions that we have related to our building. So we have greenhouse gas emissions from sources owned and operated and controlled by the reported entity, primarily from on-site combustion fuels, so natural gas, propane if you have propane, number two, oil. So those are direct emissions to the atmosphere. Indirect emissions are emissions due to the activity of a reported entity, but occur at sources owned or controlled by another entity. So primarily electric generated from off-site building power. So the current amount of electricity in our country that's generated from the burning of coal and the burning of natural gas is just an example. So electrification. So building electrification refers to replacing direct fossil fuel use, natural gas, propane, heating oil, with electricity use in a way that it reduces your overall emission while lowering the air pollutants. So electrification, as we see it in the future, is going to be renewables, so solar, wind power. I'd like to say hydro, but since I live in Phoenix, Arizona, and I keep hearing about the Colorado River being less and less and less, I'm going to tell you that is certainly in the southwest part of the United States. I think hydro is going to be a thing of the past in the relatively near future. And as I previously said, I do not think nuclear is going to go away. I think we need to increase our nuclear stock to the point where we can cover the nuclear stock as our base load, and we can use the renewables then as the up and down as necessary by grid demand. Okay, life cycle assessment is a methodology for assessing environmental impacts associated with all stages of life cycle of the building. Environmental Product Declaration, EPD. If you haven't heard of this, you're going to hear about it in the very near future. An independently verified and registered document that communicates transparent and comparable information about the life cycle environmental impact of products to enable comparison between products fulfilling the same function. If you are using manufacturers that provide products to Europe this day and age, any of the EU countries, you are already familiar with this because you are already required to do this to sell products in the EU. Okay, so carbon capture, utilization, and storage. So the process that captures carbon dioxide emissions from the source, like a coal-fired power plant or natural gas-fired combustion turbine, and either reuses or stores it so it does not enter the atmosphere. And then site carbon sequestration is a process for long-term capturing and storing carbon dioxide at the site to prevent it from entering the atmosphere. This allows stabilization of the carbon in a solid or dissolved form to avoid increase in the temperature of the atmosphere. So carbon sequestration can be biological, or it can be also geological, stored deep in the ground. And last but not least, building performance standards, a policy that requires building owners to meet policy performance targets by actively improving their building over time. These can include energy and emission targets buildings must meet to improve energy efficiency and reduce, climate impact. And just as an example, the state of California, a number of their municipalities have basically said you can't use any natural gas in any new construction, just as an example. Okay, so the position document. So generally, ASHRAE position documents are approved by the board and express views of society on specific issues. The purpose of these documents is to provide objective, authoritative background information to persons interested in issues within ASHRAE's area of expertise, particularly in areas where such information will be helpful in drafting sound and relevant public policy. So the title, purpose, and scope of our position document was approved in January of 2021. The committee began work in June of 2021. The committee began work in July of 2021. And as I said at the beginning of this presentation, the goal was to have the position document reviewed and approved prior to summer of 2022. The Task Force on Building Decarbonization approved it yesterday. So it was approved in April of 2022, and the Board of Directors, we hope, will approve it the first week in May of 2022, and then it will become an official document. The required approvals are the Document Review Subcommittee, tech committees. There's lots of TCs within ASHRAE, and then also the board of directors. So we've basically passed the first two, and we're at the stage where the board now needs to review it. This is the 7 items that you have in the decarbonization document. It's a 14-page document. You have abstract, executive summary, you have the issue, you have the background for it, you have the recommendations. So obviously this is the meat of it, and then any of the references. Now, this document also shows the progress. Obviously at this point, we're at 100% on everything as we sit here on April 20th of 2022. Okay, so building decarbonization primer. So, and again, these may seem like obvious things. Buildings are built for a purpose. Buildings must provide a healthy environment and enhance occupant well-being. So healthy from an IAQ standpoint, be at a good temperature and humidity. So the occupants' thermal comfort is important. Buildings can be places where individuals and teams can thrive and reach their collective potential through increased productivity and collaboration. And buildings can be designed and built to minimize energy and carbon emissions. That's the goal of the task force. So HVAC systems have direct and indirect carbon emissions from energy use, refrigerant emissions, and embodied emissions. So direct emissions and indirect carbon emissions are determined by where the critical emissions occur, and on-site emissions are typically considered direct emissions, and anything off-site is then typically considered indirect emissions. So building decarbonization involves the building design, the construction, operation, and the occupancy. The primary means of reducing operating carbon emissions are aggressive energy efficiency, so lowering the energy usage, electrification of the building, assuming that the electrical grid is giving us renewable energies, and decarbonization, electric grid, and delivered fuels. Okay, so this is global energy related to carbon emissions in 2020. So you can see the breakdown here: residential 17%, non-residential 10%, building construction industry 10%, other construction, so basically civil construction. Others is about 6%, industry is 23%, and transportation is 23%. So this is a global perspective. Now we take a look at this 37%, and this is how it breaks down: residential direct, so your electric bill, your natural gas bill; residential indirect, so all the other things that basically come to it; non-residential direct, and then non-residential indirect. So these are building operational carbon emissions. And then this is basically showing it in a different format. So you can see the percentages here that we just talked about. But the big thing here is energy-related embodied carbon emissions for buildings under construction in a year are basically 10% of it. So obviously we need to focus on that. Now, this is why new building embodied carbon is important. So this is a scenario of a 100,000 square foot building, all electric. The building life is 50 years. And what you'll see is these are the CO2e emissions. These are in metric tons, and these are the years, so 0 to 50. Now, what happens is as soon as you occupy the building, the embodied carbon is already there. And in this example, it's 12,000 metric tons, and that's constant through the life of the building. The operational carbon then, if we have an EUI, energy utilization intensity of 20,000 BTUs per square foot per year, then we're on this purple line here. And if we're at 40,000 BTUs per square foot per year, then we're on the red line here. So you can see that the embodied carbon plus the operational carbon, if we basically add those two together, we're adding this value of about 12,000 and this value, which looks like it's about 11,000. So that would be the total footprint for the building. So again, I can't stress the importance of operational carbon being as low as possible, even down as low as 10 to 15,000 BTUs per square foot per year certainly helps your cause when you're decreasing operational carbon. So these are global CO2 emissions reduced by mitigation measured in buildings in the 2050 net zero emissions cause. So this is the building as it is built in 2020. So on top of that, we add all the additional activity that's going to happen between now and the year 2050. So that's an increase of 90%. So if we're going to get to net zero, this is what basically has to happen. We have to have a reduction, and all these add up to 98%, which is, very aggressive. So behavior and avoided demand is the purple part here. Energy efficiency is a yellow component here. Electrification is the light blue component. Hydrogen-based, if possible, is a dark blue component. Bioenergy or biomass is the dark green. And then other renewables is a light green. And then again, other fuels or possibly even buying carbon reductions is kind of the last 2% if we're going to get to zero by 2050. So energy efficiency will need to account for roughly 30% of the global direct CO2 emissions reduction by 2050, and electrification will need to account for roughly 40% of the global direct CO2 emissions reduction by 2050. So those are some very, very large numbers. So this is how the global change in electrical demand by end use in building sectors. So this is the 2020 profile. So lighting, space cooling, appliances. So these are basically the items that are physically inside the building. So laptops, network printers, elevators, escalators, those types of things. And then this is heating. And again, this is a global average. So our activity will increase at 101%. Electrification will increase it by 37%. And then for us to then reduce it, these are the reductions that we have to have in efficiency and lighting, space cooling, in the internal products, appliances, and in heating needs. That's a reduction of 39%. And in behavior is a reduction of 9%. So again, the idea is to reduce the demand by 20 efficiency. So electrical efficiency, again, will need to account for roughly 39% of the global electrical demand reduction by 2050. And when we talk about global demand, one of the things that should be popping into your head is some type of storage, whether that's battery storage, whether that's energy storage at the site of your building, so chilled water storage, ice storage, hot water storage, those types of things are all going to be part of the future picture for demand reduction in the future. So the position documents, so the global building industry needs standards, guidelines, tools, and training. As I said, we've authorized the use of standards. We've already done some amount of training. So ASHRAE will partner with other national and global organizations to provide solutions. So ASHRAE will be addressing these issues. So global climate change position document, which we already have. We have many standards. We have our ASHRAE handbooks. There's 4 handbooks. They're renewed every 4 years. We continue to do education, and obviously the Decarbonization Task Force is a big part of this process. So these are ASHRAE standards. I know that this is not the easiest diagram to read that I'm showing you here. These are the various standards. You can see 2 columns here. These are included in the standard. These are, do they have carbon metrics included? These are under consideration. So these are the circular green check marks. These are circular white check marks. And then these are proposed, and the proposed ones are standards that aren't done yet. So standard 15 and standard 34 deal with refrigerants, the safety standard and the safety designations. Obviously, they deal with refrigerant emissions. These are the 90.1, 90.2. So this is non-residential buildings. 90.2 is residential. 90.4 is data centers. So they deal with energy efficiency. We know that operational carbon is going to be added not to the 2022 version of 90.1, but the 2025 version of 90.1. This is standard 100, energy efficiency in existing buildings. This is standard 105. So this is standard for determining and expressing the building efficiency references related to carbon. So this is 105. So it deals with energy efficiency, operational carbon, and also renewables. This is standard 189.1. So this is high performance buildings. So energy efficiency, operational carbon, the embodied carbon, refrigerant emissions, and renewables. This is 189.3. So this is high performance healthcare facilities. So again, we have check marks here in all 5 bins. So this is a 227. This is passive building design. So we have a check mark here under energy efficiency and refrigerant, and then also 228P, which is how we get to zero energy and zero carbon emissions. So there'll be operational carbon and refrigerant emissions and renewables. Okay, so these are the principles. So can we reuse existing buildings? That's certainly one of the ways to reduce embodied carbon. You keep the bones and you exchange, you basically put a new skin on it, put a new roof on it. We optimize a building through orientation and geometry. Again, if it's new construction, we can do that. If we're reusing an existing building, it's hard to do that. Proprietize passive efficiencies. Optimize waste energy. If we are still burning fossil fuels in any way, shape, or form, is there any way to get the energy capture? Minimize embodied carbon. Electrify all our loads, so space and water heating, and also cooling. Use low GWP refrigerants in the future. Certainly have on-site renewables if space allows. You can also purchase off-site renewables. And, as a last guess, if you can't get to zero carbon that way, then you can purchase carbon offsets. Okay, so opportunities, energy efficiency. So substantial untapped potential in both new and existing buildings. Electrification, assuming a decarbonized power sector. That's a big assumption. Using electrical heating, cooling, and hot water needs instead of fossil fuels can greatly reduce building emissions. Renewable energy, you utilize renewable energies. Embodied carbon, so reduce embodied carbon by reviewing alternatives if there are alternative materials available. So refrigerants, utilize low GWP refrigerants. Again, they'll be in the code starting in 2024. So these are HFO, hydrofluoroolefins, and blends of hydrofluoroolefins and HFC blends. Challenges, existing buildings. So many challenges, integrating solutions typically work best. Return on investment. So depending upon who owns the building, a lot of these, items may not meet their, return on investment. A lot of these folks have very, very aggressive return on investments. They want to see, return on investments of 2 to 4 years, and some of these things may have longer, ROIs than what they're looking for. And then certainly embodied carbon, so the lack of industry standards or codes for whole life building life cycle assessment. The EDPs, the environmental product declarations, are going to be mandated at some point in the near future in the United States. So conclusions, the decisions that ASHRAE members make in design, manufacturing, building operation management have substantial impact on building-related carbon emissions. ASHRAE standards, guidance, and education can be significantly impact these decisions. As a result, ASHRAE and its members have a critical role in decarbonizing the built environment, and you as engineers for the military certainly take on some of that role. And in our Las Vegas meeting in January of 2022, we approved the development of the decarbonization standard. So this is our bibliography. A lot of the graphs that you saw related to global energy come from the IEA, the International Energy Administration. They're headquartered in Paris. And questions and answers. Matt, I'll turn it back over to you. Feel free to contact me if you don't get your questions answered today. Only request that I have is that you identify yourself and say, hey, that you heard me speak at the Society for American Military Engineers presentation on April 20th of 2022. And Matt, I'm going to go ahead and turn it back over to you at this point in time
to
go through some of the questions.
Yeah, thanks, Don. I see one question up there. I encourage folks to post questions in the Q&A tab if you have them. I know we covered kind of a lot of material there. I'm going to start with a couple before I get to audience questions. I know that Don, you spoke quite a bit about the different refrigerants and kind of listing through a lot of what's available. What's the kind of the bottom line of the discussion? Your couple slides on refrigerants. What is what's important to know from that, and how can feds kind of use that that information to make a difference in their buildings?
Sure. So good question, Matt. So number one, the two low pressure refrigerants, R514 and R1233ZD, are actually currently available. So all the major manufacturers of centrifugal chillers is where you see low pressure refrigerants used, have both those refrigerants available as we sit here today. The medium pressure refrigerants, the most current alternative is R513A. Again, it is available again for basically helical rotary screw chillers, things where you would commonly see medium pressure refrigerants. And the only thing that isn't available off the stock at this point in time are the high pressure refrigerants, the 452, the 454, the R32, and the 466. You'll see them, as I say, starting in 2024 from manufacturers, and they'll cover all the unitary equipment, the residential type equipment, even though I know that you're not directly in the residential business, but you might have a small office building sometime that you would use something 5 tons or less. So that's kind of the bottom line and how it's coming forward. I would not use any of the low GWP alternate refrigerants unless they were currently listed in the standard, and the A2L refrigerants are not currently listed in the codes. So that would be my recommendation.
Is this a factor in retrofitting existing HVAC systems, or is this more about new systems using different refrigerants? Is there a retrofit possibility there?
So certainly, if you have a machine that's got R123 in it, it can be retrofitted to R514. If you have the high pressure refrigerant, if you have 410, it probably in the future will be able to be retrofitted to one of the low GWP alternates that we talked about. So 32, 452, 454. Now, one of the things that you have to be careful of in that change is 410 is an A1 refrigerant. So that has a certain, safety classification. The other three refrigerants I just mentioned, 32, 452, 454 have an A2L classification. So what you're going to find is when the code comes out in 2024, what you're going to see that you're changing classifications. So when you change classifications for that, you may not be able to use that same refrigerant. And the biggest one is institutional. So where we have people that cannot easily get out of the jails, prisons, hospitals, nursing homes. If you just make those changes, from that refrigerant, you have to be careful before you go to the A2L refrigerants, because you may be over the refrigerant charge limit. So that's something that, you can certainly make the transition technically, but can you stay within the code and stay within the safe guidelines? That's a whole different scenario.
Interesting. Could you also talk a little bit about some of the? You mentioned a few technologies. I know your presentation wasn't kind of focused on technologies, but you mentioned a couple that I'd like to hear a little bit more about. You mentioned chilled beam and radiant panel systems as being very efficient systems. Can you talk just a little bit about how those work, especially in retrofit, and kind of how are they so efficient?
Yep. So basically, all the current systems that we use today need a fan to move the air within the space in some way, shape, or form. Whether I have a fan coil system, whether I have a VAV system, whether I have an old multi-zone system, whether I have package unitary equipment, split unitary equipment, they all have a fan. The advantage of both radiant and chilled beam systems is, number one, you have to have dedicated outside air, because neither of those systems has the ability to remove moisture at the zone level. So radiant is basically, it looks like a ceiling tile, like a 2x4 ceiling tile. It has a metal face. So what you're looking at is a metal face. And on the part of it that you can't see above it, inside it, it has copper tubing serpentine back and forth. So the chilled water goes through the copper tubing. The surface temperature of that is maybe 55 or 56 degrees. And you basically have this radiant effect. So the heat leaves your body and it migrates to the panel. And as a result, you feel comfortable. I can speak very positively for it in that the brand new ASHRAE headquarters in Peachtree Corners, Georgia, a suburb of Atlanta, that we opened and occupied in October of 2020. We're now into a year and a half of very successful operation with Radiant. Chilled beam is different, but again, it requires dedicated outside air. And basically what you have is an induction unit that's in the ceiling. So it sits in a standard 2x4 ceiling tile. It basically works on the fact that you have a 2-row coil at the bottom of it, and you induce air from the room up through the coil, and then the high pressure induction air then sends it out in 2 linear slots that would be alongside, they would be in the 4-foot dimension at the 0 to 2 foot if I looked at a standard 2x4 panel and sent the air out basically parallel to the ceiling. Again, no fan involved. So we're heating and cooling these buildings without any terminal airside horsepower, which is really, really good.
Wow. We have a question from Don Mogi. Hopefully I'm pronouncing your name right. He's asking if ASHRAE is working with AIA to share strategy and technologies for decarbonization, or I guess I would expand that to say, what other organizations is ASHRAE working with to both, develop their strategies and share information?
So certainly we're working with the AIA because the AIA basically is responsible for the building. They use the tables from ASHRAE Standard 90.1 related to the envelope. So the walls, the glass, the roof, those types of things. We're also working with the illuminating engineers. We're working with the U.S. Green Building Council, and we're working with some of the European CIBSE, so the Charter Institute for Building Engineers. There are various other groups in the EU that we've, established alliances with. One of the things that we don't want to do is we don't want to develop a new standard that conflicts with existing standards. As you can imagine, now again, I'm assuming most of your construction certainly is in the United States. Obviously, there are military bases outside the United States, but I'm assuming that in those countries, you're building those to, the standards that the Department of Defense has, and you're using their guidance. Am I correct in saying that?
I think that's probably generally true, yes.
Right. Now, you may have products from a foreign country. Is that fair to say? Yeah. In some cases. So, that would be where you could get a conflict is, you would have an American standard, but you were using a product that was built in Europe or the Middle East or India, China, someplace like that. So, So yes, we are working diligently to make sure that we do not have conflicts.
I'm going to shift to maybe a little bit harder question, maybe outside your strike zone, but let me know. So as you probably know, the Executive Order 14057 has some very aggressive goals around from the federal government reducing their greenhouse gas emissions and other goals. One of those is net zero emissions building portfolio by 2045. Including a 50% reduction by 2032, which is really, in the scheme of things, right around the corner. Yeah. How can kind of the building performance standards and ASHRAE help drive that, especially considering that there are not a lot of new buildings going on in the federal government? Really what you're relying on is existing building stock and retrofits to make it more efficient. What are the strategies? How is that goal even possible, and how can kind of the building standards help?
Right. So one of the first things I would say is, number one, your military facilities, number one, getting them to renewable electricity or no carbon electricity as soon as possible. I mean, I think that's step number one. And, I know that in a lot of cases, I called on Luke Air Force Base here in the state of Arizona, a Marine Corps Air Station in Yuma, when there was an old Williams Air Force Base and they bought power from Salt River Project, Arizona Public Service, et cetera, et cetera. So in most cases, they are buying electricity from a utility. So I would say first thing is improve your renewable stock on your bases as much as you can, as fast as you can. Okay. Now, some places you have lots of room. There's other places you don't have room. So that's obviously, a challenge. The other thing was, even though you have existing buildings, Matt, I would say, in all cases, you can go back in and you can, make retrofits, to those buildings to make them, way, way more energy efficient, both from the envelope standpoint and then also tearing out the old existing HVAC systems, old existing lighting systems, and putting in newer high efficiency systems in all cases. And then, redoing the envelopes, redoing all the glass, put shading on the exterior, to help reduce the solar load. All those types of things are, dramatically necessary for you to even have a chance to get close to the 2045 goal, which is a real challenge. Okay. Let's not, color this thing, easy to do, because it is not easy to do. This whole process of decarbonization is brand new to us. And if I sat here and told you this is the easiest thing in the world, that would be the biggest lie I could tell. And I'm not going to say it.
No, I think, most of the people on this call probably share that, this is a huge challenge. And I think that was the goal of the administration, to put out, a very aggressive, very kind of something that's going to require an all of government approach to have any chance of succeeding. But there's so many parts of that, and such an aggressive goal is going to be complex and hard to accomplish. Another one of the executive order goals was about net zero emissions from federal procurement, including a buy clean policy to promote the use of construction materials with lower embodied emissions. Yes. How do you think that gets, incorporated? How does someone who's, a contracting officer or someone who's directing construction contracts for the federal government, how does that come to fruition where it really is able to make a difference on federal procurement?
Sure. So, first of all, getting the environmental product declaration for all the individual products. So number one, you'd have to make that a requirement before you would even consider a bid from a particular vendor, or your general contractor would then have to make that a requirement before he can get pricing on all these different products. So I think that's a requirement. Number one is you have to have that declaration, which says, here are all the various materials that we're going to use, whether it's a retrofit or new construction. You have your environmental product declarations, and then once you have those, you can see which ones of those are better than others. Like, just for example, very honestly, wood, construction, laminated beams, and those types of things is going to benefit greatly from the decarbonization process. Now, every building is not going to be made out of wood. There's high rises. I say high rises. There's mid rises that maybe go up to 10 stories, and people are reasonably comfortable with that up to 10 stories. But there's a whole lot of buildings in the United States, and I'm sure on military bases that are maybe only 1 or 2 stories high. I mean, I take a look at all the barracks that you have. Every time I'd go to a military base, I'd see tons of 2-story barracks. And they would have either a boiler and an air-cooled chiller on the end, and that's, and a fan coil in each room. That was the standard MO for as long as I called on military bases. So, they would be relatively easy to do wood construction on, and certainly they would be reasonably easy to retrofit the envelopes and make them more efficient, buildings. So,
yeah, thanks for that. John had, this will probably be the last question here. John Mogi again had another question about what age of commercial buildings would be kind of the best target for and I'm assuming a large energy efficient kind of a big retrofit on a building. When does it hit the point in that building's life cycle where you really it makes sense to go in and do a large retrofit?
Well, I would say, number one, even though we do a lot of life cycle analysis based on 25 years, I think that's a waste of time. I mean, we keep buildings 40, 50 years. The whole idea that at the end of 25 years, we go in with a wrecking ball and we start all over, I think is crazy. I mean, we have way longer lives than that. I would say if you have a building that was built before 2000, I think that would be a good candidate to start looking at doing energy efficiency retrofits on it, because from 2000 to 2010, there was kind of a level of increase in efficiency, and then it jumped up a fair amount from 2010 to 2022, where we are today. So I would certainly take a look at that, Matt.
Yeah. Well, thank you for that. We're right at the top of the hour. Don, any kind of closing comments or thoughts for folks to take away from this webinar?
Again, you have my email address. Please feel free to use me as a resource. In retirement, I've got lots of extra time. Spend most of it on ASHRAE, but I'm happy to try to help, people out. And, also what I'll do is I'll try to stay in touch with you, Matt. And then as these standards and things become available, we'll make you aware of it. So, your members and those folks that are ASHRAE members know that stuff is now accessible. So thank you.
Yeah, great. Thank you for the presentation. Very informative, and best of luck in your continued retirement.
Thanks. Take care.
Bye.